Hello, my name is Mario Aquino. I'm one of the organizers of the Strange Loop conference. And in this episode, I'm going to be talking to Joel Holdbrooks, who I know as Falcon. Joel and I work together. We've worked together in the past. And we're going to be talking about his closure library called Meander, which is something that was featured in a talk given by Jimmy Miller in 2019 at Strange Loop. If you have any questions about the conference this year, you can read more about it at thestrangeloop.com. So with that out of the way, let's get started. Falcon, how's it going?
Doing all right. How are you?
Very well. So what I wanted to talk to you about was about Meander. So I mentioned that Jimmy gave the talk on it back in 2019. And in this conversation, we can talk about where Meander has gone since he gave the talk. In the
Sure.
talk, Jimmy talks a little bit about the sort of plans for sort of short-term and long-term plans for Meander. I'd also like to talk about your inspiration for Meander and what it is for anybody who may be watching this who didn't get a chance to see Jimmy's talk, which is on YouTube for anybody viewing this discussion. If you want to watch Jimmy's talk on Meander, it's available on our YouTube channel. Falcon, can you tell me what was your inspiration for writing, or at least writing Meander in the first place?
Oh, gosh. Lots of things, honestly. Just day-to-day programming was a big part of that. Just sort of observing relationships between things that people were doing, as well as and connecting that to pattern matching. I would observe during pairing sessions, people would write code a certain way, and I was like, oh, that looks a lot like a pattern match. And then also noticing that after they had done something to get data in a certain pull certain information out of the data, then they would want to put it back together in a different way, and sort of that I started paying a lot of attention to the asymmetry in that. So we do things like we destructure, we pull data apart in one way, and then we put it back together another way, or in an entirely different way. And to me, that was kind of strange after a while, because in mathematics, you don't really work this way. The symbols move from one side of an equation to the other side of an equation, and there really isn't a difference between the two sides. Um, so this kind of bugged me for a long time, and I didn't know what was going on there, and then eventually I encountered the space uh, called rewriting, which is all about this. It's all about taking some pile of symbols and turning it into some other pile of symbols, right? And there's usually systems of these that describe how to pick one particular shape of symbols and turn them into another one. Proofs are like this. There's lots of it in logic. So I wanted to bring this sort of way of working with symbols to closure. So that was the idea and inspiration. There's more to it, but that's sort of the long and short of it.
That's one of the sort of classical problems for programs. Would you agree that programs take data that looks like one thing, and it needs to make it look like a different thing following whatever sorts of rules? And as common as that is, it seems like Meander is trying to scratch that particular itch in as a convenient and expressive way as possible.
Yeah, that's the goal. It certainly sounds easier than it actually is in practice, right? Because it turns out there are many types of, I guess I would describe it as behaviors that people, express when they're coding. And pattern matching works really well up to a certain point, using like the sort of classical approach to pattern matching that you encounter virtually everywhere. But at some point, it's not robust enough um, to do things that people are often interested in doing, such as aggregation, for example. Um, so one of the challenges has been to figure out a way to build into the system the primitives that allow for things like aggregation. Um,
So if I could stop you there just for a second, I want for anybody who's either not familiar with Meander or not familiar with pattern matching, I guess what I'd like to do is have you just describe a little bit what the idea of pattern matching is. And
Absolutely.
yeah, go ahead.
Yeah, definitely. So pattern matching, so there's many different kinds of pattern matching. I think one of the ones of one kind that most people are familiar with is our regular expressions. So those describe the shape of a string, and it'll given some string, it'll tell you whether or not the string that you have matches the pattern. And there's extensions to regex that probably everyone's familiar with that would allow grouping and capturing and this kind of thing. Um, but the general idea is that you have a structure which looks very much like another structure, a concrete structure. So this could be a list, could be a vector, could be a set or a map, which I'll talk about in a minute because those are very different from the other two. It could be numbers, what have you, right? Um, so the idea is that using that description or that structure, you have these placeholders or these variables, and the idea is that the variables will bind to items or elements of the structure that you're matching, and then make those accessible to you for programming. So a really simple example might be, let's say I'm trying to well, the most simplest one is like let's say that I have a variable x, or x can be anything. So if I'm going to match that variable x, it could match with anything in the universe. Let's just say 1, and then x would be bound to 1, and then I have a usually what's called the right hand side of a match, which is where I can use that binding x. So I might add x or put x in a box or something like that. But then you can grow this out to something like, well, let's say I want to describe a list, maybe of 3 elements. So I might say, well, I have a list of X, Y, and Z, and then you hand me 1, 2, and 3. I can line those up. X is 1, Y is 2, and Z is 3, and then I can go on and use those. Um, I think many people encounter a type of pattern matching called destructuring in the field. So it's in pretty much every mainstream language that I can think of now, but certainly ones that um, people use a lot, like JavaScript. You've got destructuring there. So it's very similar. So you have an object destructure or an array destructure. So it's looking for something that looks like an object or looks like an array, and pulls those things apart and makes those bindings accessible. So I say something that would be closer to like a more mathematical definition of it would be that you're given a pattern and an object that it's a function that if the object matches the pattern, then you get a set of bindings out of it, which is just sort of mapping from a variable to a value. Now, for most of the way people use pattern matching, that they do what I just described it. So you've got a pattern match, and then you've got a right-hand side, which is usually your ordinary code. But in rewriting, Yeah, it's just another pattern on the right side, except the difference is instead of that pattern being for matching, it's going to take those bindings and then build a new structure out of it. So in the XYZ example I gave you, let's say I match a list XYZ. Maybe on the right-hand side, I have a pattern that just says X and Z. So this pattern says, if I have a list XYZ, well, then I want you to turn that into the list XZ, right? So this is the general idea here. So you're not coding on the right side. You're just applying the bindings you got from the left side to the right side to produce more data.
Right on. So the idea of Meander is to give you ways of doing pattern matched rewriting where you express patterns on the left and right side, or
Yeah.
you can express patterns on the right side. And so besides patterns, what else can you, like, what can you incorporate into those patterns on the right side, let's say?
Well, I mean, it depends on what you allow, what your language allows. So Meander sits on top of Clojure, so it's going to try and make some things like function application, available to you. So let's suppose I go back to that list where I matched X, Y, and Z. Then maybe I want to turn all of those into strings. So there's a way to say on the right-hand side, hey, when you're you would say substituting. When you're substituting X over here, I want you to call this function on that value. So maybe you call stir on it or something like that. But if we were maybe using this language in isolation, in its own space, maybe it wouldn't have that feature because it doesn't have a host language that it's interacting with. So it just depends on what the language allows for. But that would be arguably the big one, right? Because you want to be able to talk to the host language, in particular for things that the pattern matching language can't express yet, right? And I say yet because there are lots of things that are currently available on the main branch of the project that you can't do, that I have plans to make work um, uh, on the new version that I've been working on.
So you mentioned the host language, and I want to ask, so you mentioned being able to use Meander in Clojure. Does Meander also work in ClojureScript?
It does. Yep. So in ClojureScript, it actually works on JavaScript objects, which is a lot of fun because it has a very liberal take on what it means to pattern match an object. So there you can anything that basically has properties on it, you can pattern match with. So it's fun to pull it into Node and pattern match on process, and that pattern matching could work like on pulling out system information or whatever you want, and then pattern matching on it. I haven't done as much in JavaScript as I'd like though, but you can do it, and you can also match on arrays as well. You can further extend the language too. Meander has facilities for extending it. So if you wanted to have it do more interesting things that it doesn't do out of the box, then you can make it do other things.
So I want to kind of go back to something that you were just saying moments ago about what is possible to do on, let's say, one branch of the repository for the project that you have, and kind of relate that to, I guess, future plans, near or sort of distant future plans for Meander, the things that you want to try to focus on feature-wise or anything else.
Right. So like I mentioned earlier, the kind of one of the big drivers for me in this project is I want um, a symmetry. It's something that I would like to have more of. I really like this idea of symmetry. I also like the idea of duality, and I want to have those ideas be at hand in this language.
Can you, before you
Currently,
go much
oh,
further, can you say a little bit about what you mean by symmetry and duality, just for
um,
context?
yeah. So for symmetry, what I just mean is that something that you can express on the left-hand side of a rewrite rule, I believe you should also be able to express on the right-hand side. And currently, there are constructs that exist on the left-hand side that don't exist on the right-hand side. And the main reason that that's the case is that um, I didn't have a semantic or an idea of how to make that work. I didn't have a notion of. So pattern matching has this notion of failure, right? Which is that if I give it the wrong type of data, it fails to match the pattern. Okay, so that's a pretty easy thing to do. Um, when I was doing the right hand side, I didn't know what the semantic for failure should be, or I didn't have a semantic for failure. But since 2019, I've figured it out, right? Um, and so that's basically that was basically preventing me from having that property of you can whatever you can draw on the left, you can draw on the right, and there's a semantic that makes sense for both. Um, part of the thing that was holding me back there is a constraint on logic variables. So a logic variable, for anyone that doesn't know, is a variable which represents the same or equivalent value wherever it appears. So if I have a going back to that list again, if I have a list of x, it's going to be looking for a list of like 1 1 2 2. X has to be the same value. when you're when you have a disjunction or an or in a pattern match, you're saying I'm going to match either this thing or that thing. Now, in pretty much every system that exists, you have to have the same logic variables in both sides, or they have to have been bound elsewhere. So I can't say or x y because I don't know what to do with that. If maybe I get x, maybe I get y, but I don't know how to express the lack of X or the lack of Y for the right side. Um, so what I decided is that on the right hand side, if you refer to something that's not bound, so if that X isn't bound or that Y isn't bound, it'll cause the substitution to fail. You know, so that's the idea. That way, you don't have this limitation of not being able um, to uh, you have to be required to write things a certain way. And I think there's utility in that, being able to have those kinds of semantics. And part of this is responding to the fact that people um, constantly bring this up as a as a pain point, right? This constraint. And I don't want to appeal to pragmatism too much here, but I think it's really worth listening to devs on this kind of things. So at the end of the day, you want to take these cool ideas and give them to people, but you also don't want to limit yourself to whatever rigid sort of framework might exist in academia, because maybe that's not as useful to people in practice, and that you can come up with something to make it useful. So that's yeah. So now there's a way to have that symmetry. You can use or on the left, you can use or on the right, but if you have things that aren't bound, then it's going to fail. you know um, so you could say something like, oh, I want to match X and then I want to rewrite it to Y. That's never going to work, because Y will never get bound, or will never be bound. And maybe that sounds like nonsense, but it's got a semantic. So right. Anyway, um, all right. I'm
So,
rambling there.
so beyond trying to add symmetry, or trying to get closer to a symmetry between the left and right side, is there anything you can say about performance in the library? I remember that was something
Oh
that
yeah,
Jimmy talked about a little bit in the talk in 2019.
yeah. So we have we have made leaps and bounds in terms of performance. we people will bring things to us. So there's a by the way, there's a channel Clojurian in Slack called Meander. Um, we always welcome people to come there and complain, tell us what's not working out for them, tell us when things are slow, when maybe they think they should be fast. And fortunately, we have had many people do this. They'll give us an example of something that's, hey, this is 10 times slower than Clojure. And we'll go take a look at that. And hey, maybe we can make it go faster because we might see something, oh, well, this pattern, um, we can reduce it to this or rewrite it to that. And so we're getting fewer and fewer of those kinds of requests now because I think we've closed the gap on most of the big ones. And in many cases we can get very, very close to handwritten code, sometimes faster depending on the pattern and what's going on. And that largely depends on two things. First of all, when people handwrite code, they're going to handwrite code in a way that's convenient for them to write. So maybe they'll do things that aren't actually very performant. And sometimes, maybe the problem that someone's trying to solve, um, they're not familiar with it and they write it a certain way and has certain performance characteristics that make it slower or something like this. What we're aiming for is we're trying to be as fast as, probably the code that you would say, hey, that's a pretty good solution, that, that's what we want to aim for. And so we've definitely made a lot of improvements there. The next version of the library, I think, will continue to have more performance improvements and probably I think actually even some memory improvements too. I haven't spent a lot of time looking at that, but because of the what I just was talking about, symmetry, right? So we have the same things on both sides. For pure rewriting, we can exploit a lot of the relationship between the left and right hand side, and we can close the gap on generating code. We do a lot of dead code elimination. There's a lot of inference that we can do because the both sides are speaking the same language.
Right on. Well, Joel, I want to thank you for sitting down with me today. I look forward to watching the progress of Meander. Do you have an idea for timeline when you would like to, or I should say, what are the things that you want to try to tackle before doing next major release?
So yeah, so I definitely want to get the next iteration of the project out this year. Last year with COVID, my kids were home. We had homeschooling. My open source work, I couldn't keep up with it. But now my kids are going back to school, and I'm able to get more my job stuff done like I'm supposed to. So I have more time for open source. So I plan on having it released sometime this year. I just want to quickly say that the challenge in getting it from where it is now, from where it was to where it is now, is that I wanted to address all of the problems that people have come to me with. People want to have, they want to be able to have an interpreter so they can hand quoted patterns in or construct patterns and, no macros. I still want macros. People want explanations. They want to know why something didn't do what they think it's supposed to do. I want that too, because I have to debug these things occasionally. And I also wanted, like I said, a unified framework for doing all of this. And that took time to figure out how to build. Now that I've got that figured out and I'm able to build on top of this framework to deliver all of those things, it's mostly a large amount of it is testing everything, and solving problems that I didn't anticipate. I dealt with some problems of divergence and things just kind of spinning on some of these rewrites, and that's just debugging stuff that you have to deal with. But fortunately, I've closed a lot of those gaps, and I'm much closer now than I was before. So before the end of the year, I don't want to promise any specific dates or anything, but I definitely believe before the end of the year.
Awesome. Well, thank you once again. So I have been talking to Joel Holdbrooks, who is known as No Prompt on lots of places. I know him as Falcon. And thank you for watching. For folks who are considering coming to Strange Loop this year, we hope to see you. We also hope to put ticket availability online sometime soonish. Please watch the Strange Loop Twitter account to learn more, or the website. Thank you.